All right, so this screencast is going to take you through how to name polyatomic acids and bases. You've really already learned how to name the bases, but we'll review that. So you're going to learn how to name binary acids and polyatomic acids through. So naming bases, we're just going to start off with this one. It's really easy. You name the cation, followed by the anion, which is going to be hydroxide, with the ending IDE. So just like we've been doing all along with ionic compounds. So you're just going to look at what's on the chart. Sodium is the metal, and then it's bonded to hydroxide. And remember, it ends in IDE because when you look on the chart, hydroxide is, or it does already end in IDE. So you will know that it's a base if you see the AQ. So the AQ behind it tells you that that is going to be a base because it's in water and it's dissociated. So we have sodium hydroxide, calcium hydroxide, potassium hydroxide. There's a whole bunch of different ones. Binary acids we actually have covered a little bit, but you will know the name, you will know to name this as an acid because of the aqueous and the H in the front. So when you see these guys, there's only 6 of them. It's whenever hydrogen is combined with fluorine, chlorine, bromine, iodine, sulfur, and selenium. So it's a binary acid, so it's hydrogen plus one other element. But again, there's only 6. You'll write hydro as like a prefix to it, and then you'll add the name of the nonmetal shortened with the ending ic. So chloric or fluoric or bromic. And then your second word is acid. So like HCl with the aqueous behind it is hydrochloric acid. HF would be hydrofluoric acid. HS would be hydrosulfuric acid. So these are binary. They're not going to be a polyatomic ion. It's just going to be hydrogen bonded to one of these 6 elements, one of these 6 nonmetals. So the polyatomic acids are a little bit different. The first part of the name is the name of the polyatomic ion, which is shortened. So instead of putting hydro at the front of it, we kind of ignore that the hydrogen is there. And we take care of the fact that it's an acid by putting the word acid at the end of it. So you're going to use one of 2 endings. So ic will be the anion name, or ic will be the ending if the anion ends in ate, and us if the anion ends in ite. So ate and ite mean different numbers of oxygens. Ites have less oxygens than ates do. And so if it ends in ate, you'll put the ic at the end. If it ends in ite, you'll change it to us. Well, how will you recognize these? They're always going to have a hydrogen before them. So hydrogen plus NO3, this is the hydrogen plus the nitrate ion, so we would call this nitric acid. HNO2, that's going to be the nitrite ion, so we would call it nitrous acid. And how do you recognize again that it's going to be the acid and not just a regular polyatomic compound? Because it's going to have a hydrogen in front of it. So let's do some practice. I'll do these with you and we'll go over some more in class. So I recognize them as acids because they have hydrogen in front of them. So hydrogen plus a polyatomic ion. Well, I have carbon 8. Well, it ends in 8. So that means it's going to be ic. So this is going to be carbonic acid. The next one, H2SO4, is sulfate. So it's going to be sulfuric acid. And then H2SO3 is sulfite, so I'm going to name this sulfus acid. So kind of different, but we'll do some more practice in class with acids and with bases.